first thing we have here is a diagram, or what we call the anatomy of a parabola. Now, a parabola is the name of the graph you get when you graph a quadratic. And I want you to notice the different elements or parts of the graph. First of all, you have the axis of symmetry. Now, that's really kind of like an invisible line that goes down the middle of the parabola, and it goes through a special point that we call the vertex. The vertex is the turnaround point. It's where, in this case, from this parabola's perspective, we're going down and now we're going back up again. So it's a point of change on the parabola. We also have the x-intercepts, which we spent a lot of time learning how to find using the quadratic formula, completing the square, square roots, and even factoring. And lastly, we have a y-intercept, a single y-intercept. Now, you're going to find x-intercepts when the y value is 0. It's kind of backwards, because then the y-intercepts you find when you let the x be 0. The graph of a quadratic function is called a parabola. To produce a good-looking graph, we must include the vertex and at least 4 other points whenever possible. So 5 points altogether makes a really good-looking parabola. And you can see in this diagram, I'll highlight them for you. First we have the vertex. There's 1, there's 2, there's 3, there's 4, there's 5. Now this parabola actually has 7 points plotted on it, and it gives you an even better view. Obviously, the more points, the better. And the vertex has a special name in algebra. The vertex is referred to as HK. Now that HK, we'll discuss 2 forms of a parabola that are commonly used. The first one is called standard form. To find the vertex, we use a special formula. The h, or the x-coordinate of the vertex, is negative b over 2a. Now, once we've used the formula to find the h part, or the x-coordinate of the vertex, we're going to use substitution to find the y-coordinate. It says find the vertex of the parabola for the function y equals x squared minus 6x plus 1. Our first step is we're going to identify what a and b are, since we need to use those for our formula. A is the number in front of x squared, and since you don't see a number, the number is 1. B is the number in front of x, and that's negative 6. Those are the 2 numbers we need for our formula. So we're going to, step 2, substitute those values into the formula. H equals negative b over 2a. Negative b, notice there's a double negative, 1 for the formula and 1 for the number, all over 2a. That's positive 6 on top over 2, or 3. 3 is the x-coordinate of the vertex. Now, to find the y-coordinate, we're going to substitute our answer into the original equation. So the k value, or the y value of the vertex, is x squared minus 6x plus 1. And that x value that we're going to substitute is the number we just found here. It's going to go here and here. So 3 and 3. 3 squared is 9. 6 times 3 is negative 18 plus 1. 9 minus 18 is negative 9 plus 1, or negative 8. Step 4, write both numbers you have found as a point. 3 is the x, negative 8 is the y, and we're done. Example 2. We'll do another one. Step 1 was to identify the a and the b values. In this case, the a is a negative 3, the b is a 6. Step number 2, we're going to plug that into the formula. H equals negative b over 2a, which is negative 6 over 2a, which is negative 6 over negative 6, or positive 1. Step 3, we take that positive 1 value and we substitute it into the original equation. So the k value is negative 3 times 1 squared plus 6 times 1 plus 5, which is negative 3 plus 6 plus 5, which is 3 plus 5, or 8. Step 4 is to take the two values we've calculated and to put them as a point. 1 is the x-coordinate of the vertex, and 8 is the y-coordinate of the vertex. Now, how would we graph a parabola in standard form? We first have to do what we've done in the last two examples. We have to find the vertex. Next, we'll create a table with the vertex at the center, and then fill in the neighborhood of numbers around the vertex. In mathematics, a neighborhood is the same thing as you could think of on your street. It's the ones to the left and to the right. So we're going to graph this function, y equals 2x squared minus 8x plus 3. Off to the side here, I'm going to find the vertex. The first thing I need to do is to find that negative b over 2a value. After having identified that a is 2 and b is negative 8, negative b is negative negative 8, double negative, because we have negative from the formula and a negative from the number, over 2a. 2 times 2. This is positive 8 over 4, or 2. We need to find the y-coordinate also. But more than that, we need to find a lot of y-coordinates. So we're going to take this 2, and it is going to go in the input part of our table. We're going to put it at the middle. So now there's 1, 2, 3, 4, 5 slots. We're going to put it in the third slot. And now we're going to fill in a neighborhood around the 2. So obviously there's 1. On the other side there's 3. You have 0. You have 4. We're going to take these 5 numbers, and we chose this middle one special as the vertex number. We're going to take those 5 numbers and substitute them into the equation. But let me share with you some symmetry. Is the fact that the right side of the parabola and the left side of the parabola are exactly the same. You can fold this over on the axis of symmetry. If you can find the value for 1, you have also found the value for 3. It's a reflection. If you have found the value for 0, you have also found the value for 4 because of reflection. It's symmetric. Now, one other hint for you. The number at the end of the equation, that c value, is the y-intercept. The y-intercept is when x is 0. So without even calculating, I can fill in the output as 3. But think about it. If you put 0 in for x, it's 2 times 0 squared, which is 0, minus negative 8 times 0, which is 0. So I have 0 and a 0 and a plus 3. So this has to be plus 3. Well, that means I also just found the number for 4. See, if I trace it down here, it's the same number because of symmetry. So really all I have to do is calculate 2 other numbers, because I can find the number for 1 and it will fill in for 3, and then I'll find the number for 2. You can do this with a calculator, you can do this with a piece of scratch paper, or you can do this in your head. I'm going to do this in my head. I'm going to take the number 1, and I'm going to substitute it here. I'm going to say 2 times 1 squared. Okay, 1 squared is 1, so 2 times 1 is 2. 2 minus 8 times 1. 8 times 1 is 8. So it's 2 minus 8. That's negative 6. Negative 6 plus 3 is negative 3. And so will this value on the other side. Now, if you can't do that in your head, let's say you're using a piece of scratch paper, all you got to do is substitute the number 1 in place of x. Or if you have a calculator, even better. Put this expression in your calculator. You should get negative 3. I'll show you for the last one, 2. So we're going to have 2 times 2 squared minus 8 times 2 plus 3. 2 times 2 squared. 2 squared is the first thing I should do. It's an exponent. 2 squared is 4. 4 times 2 is 8. Minus 8 times 2, so minus 16 plus 3. Go back to the beginning. 8 minus 16 is negative 8 plus 3, negative 5. Now I'm not quite done. I have my table of inputs and outputs, but I don't have a graph. I've got to put these numbers on a graph. So 0 goes with 3. That would be this point here. When you connect these points together, they need to be in a nice smooth curve. No harsh straight lines. Just do the best you can. Alright, you're not a computer. We're going to show you in a minute how the computer would draw these. Okay, there we go. There's my sketch.